We are into transforming a general equation into the standard form of equations for an ellipse. So the general equation for an ellipse has this form: ax squared plus cy squared plus dx plus ey plus f is equal to 0, where ac is greater than 0. What that means is the product of the coefficients of x squared and y squared is positive, and that can happen if both of them are positive or both of them are negative. If we have a negative coefficients, let's say for example negative 6x squared, and this one is negative 10y squared. So this one is a candidate equation for an ellipse. If we want to turn that in such a way that their coefficients are both positive, all you have to do is multiply that by 1 or by negative 1, and what you will obtain is something like this. Multiply negative 1 to your equation, you will produce an equivalent equation such as this. So this is equivalent to that one. The reason why we did this is because our equations are written in such a way that the coefficients of your x and y are positive. Okay, so to write that in standard form, our goal is to get here. This one is our equation when the principal axis is horizontal. This one is our equation when the principal axis is vertical. A squared is the larger between the two denominators. C squared is equal to A squared minus B squared, and A is greater than B. Okay, what is the purpose of C? C will help us find the focus of your ellipse. And A here will tell us the length of your major axis. The length of the major axis is 2A. The length of your minor axis is 2B. Example 1.23. This is the same numbering I am using in my book. So you will see this in example 1.23. Let us choose B. So how do we write this in standard form? Our goal is to get here. Okay, so we do not know yet. We do not know yet if it's going to be this form or this form. Okay, so we begin. Okay, this one is unusual because the coefficient of x squared is not 1. Okay, we must begin by writing that in such a way that the coefficient of x squared is 1. Okay, so this is what we do. We rearrange the terms, and then we factor out 6 from these two terms. We factor out 10 from these two terms. What happens next? If you want to check if you did the right factoring, all you have to do is multiply 6 back to your binomial. Okay, 6 times x squared is 6x squared. 6 times 6x is 36x. The same with this one. Just multiply 10 back to each of the terms. 10 times y squared is that one. 10 times negative 2y is that one. What do we do next? We do what we had been doing when we were completing the square for a parabola and circle. You divide the coefficient of the linear term by 2. You square it, and then you add it to the two terms. You divide the coefficient of the linear term. This is the linear term because this is a degree 1 term. You divide the coefficient of the linear term by 2. That's negative 1. You square it, and then you add it. Now, normally, we will just add 9 and 1 to this. But we cannot do that because 6 must be multiplied first to 9. So, this one is 9. 6 times 9 is 54. So, in effect, you added 54 here. You added 54 to this side of your equation. 10 times 1 is 10. It's not only 9 and 1 that you must add. It's 54 and 10. So, this one now is the square of a binomial. The same with this. And no, look at this. This is 60. We want this to be 1. How do you do that? Well, we divide everything by 60 and we cancel common factors, and when we came up with your equation in standard form. Okay, so we are not required to produce the center to identify A and B, but let's do it. So our center is negative 3, 1. No, not center. Yeah, this is the center. Okay, A is the square root of 10, B is square root of 6, and this one has a principal axis that is horizontal. Let us go to another one. Again, our goal is to go here. We have this. This is almost done. Actually, this is almost done. But this one is 400 or 4,225. So how do we write it in standard form? This should be 1. And this one should be 1 also. Okay, so look at that, look at that, look at that. 1. And the coefficient of your numerator there is 1. So how do we do that? We divide everything by 4225. Okay, so this becomes 1. And, well, I wrote this book. So I intentionally wrote or chose the coefficients to be 25 and 169 so that we can easily factor out or we can easily cancel common factors. So 4225 is just equal to 25 times 169. We cancel common factors. Okay, cancel common factor. And we came up with this one. This is now in standard form. In particular, this conforms with this standard equation. We are not required to identify the center, but let's do it. What's the center of this ellipse? It's 2, 3. A squared is 169. So A is the square root of 169, which is 13. B squared is 25. So B is equal to the square root of 25, which is 5. And since our A squared, the larger denominator, is under x, under the term involving x, our principal axis is horizontal.